Assalamualaikum and good day to everyone. My name is Nasriyah binti Zakaria. Today I will present to you the demonstration of Sds-Page video prepared for BIO552. Sds-Page stands for sodium dodecyl sulfate polyacrylamide gel electrophoresis, which is usually used to obtain high-resolution separation of complex mixture of protein based on molecular protein weight and electrophoretic mobility. Sds-Page principle states that when charged molecules are placed in an electric field, the molecule will move to the electrode of the opposite side. In Sds-Page, SDS acts as detergent to break the protein of disulfide bond and alter the tertiary structure of the protein with the help of some reducing agent. The ionic detergent denatures and attaches the protein and masses and makes them uniformly negative. Thus, along the electrophoretic system, the polypeptide migration is determined by the molecular weight. So, smaller molecules which has low resistance to the gel will move faster compared to the larger molecule. This video will demonstrate how to perform Sds-Page for protein characterization. These are the material and apparatus that we need to conduct the experiment. First, insert the short plate and a 1mm spacer plate into the casting frame. Make sure the feet of the casting frame are on the bottom. Make sure the plates are also leveled at the bottom, then tighten the clamp to secure the position of the plates. Next, install the casting frame with the plates onto the casting stand and make sure the setup is tight and secured. Pipette DD water halfway up the plates to check the seal of the setup. Observe if any DD water leaks, and if there are no leaks, remove the DD water using filter paper until it's almost dry. Prepare the 12% resolving gel solution in a 50 ml Falcon tube after the gel casting is set up. Mix 3.3 ml of DD water, 4.0 ml of 30% acrylamide solution, 2.5 ml of lower stock, and 100 microliters of 10% SDS together. Make sure to wear a neutral glove when handling acrylamide solution as it is neurotoxin. Add 10 microliters of 10% APS and 4 microliters of TMAT before pouring the gel. Please take note that TMAT has to be added in the fume hood due to its strong odor. Please take note that TMAT catalyzes polymerization of acrylamide. We need to add TMAT at the last step in order to avoid gel from setting up before it is ready to be pipetted in between the plates. Then, mix gently and immediately pipette the resolving gel solution in between the plates with the glass pipette until the resolving gel reaches just above the green line or approximately 1 cm from the top of the short plate. Monitor the plates to ensure there is no leak at the bottom of the plates. Pipette 100 microliters of isopropanol on the resolving gel and observe thin layer on the gel. Prepare the stacking gel solution in another 50 ml Falcon tube while waiting for the resolving gel to polymerize. Mix 1.35 ml DD water, 0.335 ml acrylamide solution, 0.25 ml upper stock, and 20 microliters of 10% SDS. Drain the isopropanol once the resolving gel has formed, which takes roughly 30 minutes. Rinse the top of gel with DD water and dry with filter paper. Add 20 microliters of 10% APS and 2 microliters of TMAT into the stacking gel solution right before pouring the stacking gel and mix well. Pipette 1 ml of stacking gel solution on top of the resolving gel in between the plates immediately. fill to the top, then insert the comb into the solution. Wait for the gel to polymerize. Undip the casting frame with the gels from the casting stand after the gel is formed. Remove the glass plates from the casting frame carefully. Wrap the plates carefully in a wet towel and saran wrap, then store in the cold room for 1 week. Next, we go to the sample preparation step. First, label the microfuge tubes corresponding to the samples. Pipette 40 microliters of the fish extract into the microfuge tube and add 40 microliters of sample buffer. Heat the tube at 100 degrees Celsius for 3 minutes, then pulse centrifuge for 5 seconds. Remove the gel from the saran wrap and paper towel. Secure the gel with the short plate facing inwards onto the running module. Each running module can hold 2 gels. If only 1 gel is being run, you will need to use buffer dam in place of the second gel. Do not directly label your plates with tape because this will prevent the gel from running properly. Instead, plates can be directly labeled with a permanent marker. Each tank can place 2 running modules, which will be 4 gels altogether. Insert the running module into the tank and make sure the module properly inserts into the slot in the tank. At this point, check to see if the lid fits properly. Pour the 10 times diluted running buffer solution into the running module between the 2 plates until wells on the 2 plates are fully submerged. Check to make sure the running modules aren't leaking any buffer solution into the tank. The tank only needs to be filled halfway with the buffer solution of running 2 gels. Remove the comb to see each well clearly. Install the loading card on the gel to make it easier to load the sample properly into each lane. Load 10 microliters of sample solution into each well. The pipette tip should be inserted into the well in between the plates, deep enough to prevent overflow of the sample to the neighboring lanes. Release the sample solution into the lane slowly. Remove the pipette tip. Change the tip, then load another sample once complete. For the molecular weight marker, you also need to load 10 microliters into the well and it should be loaded in one of the center lanes for easy comparison. Close the lid on the tank when all the samples are loaded. Insert the electrodes properly into the power supply. Red wire into the red slot and black wire into the black slot. Set the power to 20 mA per plate and run for 1 hour. For instance, if 4 plates are being run, the power should be set at 80 mA. The power can also be set to voltage. The voltage used is not dependent on the number of plates, so a consistent voltage can be used to run any number of plates. For example, a consistent 120 volts can be used. Observe the sample or standard solution to be condensed into a thin band through the stacking gel. The band will gradually migrate down the resolving gel. Stop the run when the blue dyes have reached close to the bottom of the gel. Unplug the power supply, then remove the running module from the tank and drain the running buffer. Remove the glass plates carefully from the running module, then carefully use the gel releaser to remove the gel from the glass plates. Trim off the stacking gel carefully before proceeding to staining. Transfer the gel into a square petri dish. Pour the Comessi blue staining solution into the petri dish, submerging the gel fully. Place the square petri dish in a metal tray to avoid spillage in the incubator. Place in a 50 degrees Celsius incubator for 30 minutes. After 30 minutes, remove the gel with the tweezer and make sure you can observe clear bands on the gels before discarding the staining solution and replacing it with the destaining solution. When destaining, add a piece of Kim wipe or absorb paper towel to help absorb the dye. Destain at 50 degrees Celsius for 30 minutes with periodic swirling to facilitate the destaining process. You may also want to change the destaining solution every 50 minutes until the background of the gel is transparent. When the destaining is complete, store the gel in dirty water until you can scan and analyze it with the densitometer. Dispose of any liquid acrylamide containing solution in the acrylamide waste container properly. Polymerized gel can be disposed directly in the garbage, while the staining and destaining solution can be disposed into non-halogenated waste container.